On the 14th of August 2003, the power went out in New York City. Small blackouts affecting individual blocks or neighbourhoods were not unheard of, but this was something much bigger. In fact, this was a loss of power that affected not just New York, but a huge part of the northeastern United States and a large part of the Canadian province of Ontario. This was a blackout that would, in some cases permanently, affect more than 55 million people. The system of power lines which crisscross a country is often referred to as that country's grid. This reflects the fact that these lines are part of a massive interconnected machine. This machine links the power stations that generate electricity to the homes, industries and businesses that use it. This grid must be carefully managed. It is difficult to store electricity once it has been generated, and so the amount of electricity generated must match the demand for electricity at all times, and this power must be distributed to where it is needed without overloading any of the equipment on the network. Sophisticated computer systems have been developed to help monitor and manage the distribution of electricity through the grid, and the process is overseen around the clock by thousands of workers whose job it is to ensure that the electricity supply is safe, stable, and continuous. It is thanks to their diligent work and to the systems which underpin the grid that power outages are, today, a relatively rare occurrence. On the 14th of August 2003, starting at around 4:10 p.m, a series of power outages began affecting the northeastern United States and the Canadian province of Ontario. Affected cities included Detroit, Cleveland, Akron, Toledo, Newark, and New York in the US, and Toronto, Hamilton, London, and Windsor in Canada. The effect was immediate and dramatic. Elevators jerked to a stop between floors. Underground trains stalled in tunnels far beneath the streets. The water supply in some buildings failed, as there was no electricity to power water pumps. Traffic lights went dark, leading to immediate traffic jams. Computer systems shut off. Televisions and radios fell silent. Lights went out, and air conditioning units, in heavy use on that hot August day, stopped working altogether. In many cities, workers flooded out onto the streets. In New York, much of the public transportation network was now out of action, leaving people with little choice but to walk. The police asked for volunteers to help direct traffic at busy interchanges, while elsewhere, streets filled with pedestrians, many of whom were unused to navigating the city entirely on foot. Transit issues were further worsened by the fact that, without power, most gas stations could not pump fuel. Many cars and trucks that were low on fuel when the blackout began were very quickly stranded. Some border control checkpoints were also taken out of action, leading to massive queues. For many people, this was a stressful, frightening, or inconvenient situation. For others, it was a break from routine that was almost enjoyable. Some workers chose to sleep over at their offices or bed down in parks for the night. Bars remained open, selling off their supplies of alcohol from rapidly warming fridges. Restaurants and food vendors rushed to sell off or give away perishable foods before they spoiled in the heat, and block parties were held in the darkened streets of many neighbourhoods. Most forms of organised entertainment, however, were called off on safety grounds. A Major League Baseball game in New York was cancelled, along with numerous concerts, sporting and cultural events. Where generators were available, some venues were able to carry on. A concert at a stage in Central Park in New York went ahead as scheduled, although it ultimately had to be cut short so that patrons could navigate their way out of the park before nightfall. Most computers failed, but some people were able to connect to the internet using dial-up connections. The landline phone network, though it struggled with the volume of calls, remained operational, as did some mobile phones. In New York, the backup generators supporting Verizon's network failed several times, taking the phone system of the emergency services out of action. Amateur radio operators stepped in using personal equipment to help hospitals and emergency responders communicate. At the Cedar Point amusement park in Sandusky, riders had to be evacuated from several rides that had stopped in place without power, including a 62-meter or 205-foot tall roller coaster. Some radio and television stations, after being momentarily knocked off air, were able to continue broadcasting using power from on-site generators, distributing information for those affected. While millions of people were able to get by, for many the blackout was a dire emergency. Hundreds of people found themselves stranded in elevators, with conditions therein soon becoming unbearably hot. Commuters on board underground trains were stranded between stations. In hospitals, if generator power was not available, doctors had to suspend non-essential treatments and rely on paper-based backup systems. The intense heat of the day left many people at risk of heat-related illness. The loss of water pressure not only cut off the water supply in some areas, but also resulted in contamination of the water supply in others. There were multiple accidental releases of raw sewage across the affected area. Residents in Detroit were advised to boil all water before drinking, and schools and restaurants were shut until they could be checked for contamination. Many industrial installations were shut down. System failures at a chemical plant near Ontario resulted in a leak of toxic material into a nearby lake, while an oil refinery near Detroit was rocked by a small explosion, necessitating a complete evacuation of the surrounding area. 9 nuclear power plants were shut down on safety grounds. As people across the affected area fired up generators, some of which had not been maintained in good condition, reports of several deaths from carbon monoxide poisoning came in. Elsewhere, as people lit candles to provide light to see by, numerous small fires were started, resulting in several deaths. Without traffic lights and streetlights, there was an increase in traffic accidents. Pharmacies were forced to close, leaving people without access to prescription medication. Access to food and water was limited, putting people suffering from diabetes or other conditions affected by diet at risk. Medical conditions of all kinds were exacerbated by stress, heat, and exertion. It is estimated that, in total, the blackout cost at least 100 people their lives. Recovery from the blackout varied from place to place. Some areas were without power for just a couple of hours, while others faced rolling blackouts for weeks. Still others had to spend many days decontaminating water supplies, clearing roads, and fixing other issues that had resulted from the blackout. The question of what had caused it was a significant one. In the days and weeks after the blackout, many theories were suggested. Public figures in the US blamed the blackout on facilities in Canada. Public figures in Canada blamed the blackout on facilities in the US. It was not until much later, after a significant investigation, that a definitive sequence of events was established. Power lines are used to direct electricity generated at power plants to the areas where it is needed. As the current carried by a particular line increases, the line itself may heat up as a result of electrical resistance. This heat can cause the line to expand, which in turn may cause the line to sag in between the towers which support it. If a given line should sag far enough, there is a chance that it could come into contact with something below the line, such as a building or a tree. Should a power line touch an object on the ground, a short circuit might occur, resulting in a massive increase in the current flowing through the line. Excessively high current can permanently damage power lines. To prevent damage, automated systems are in place to detect massive increases in current and redirect the flow of electricity through other nearby power lines whenever this occurs. This was what had happened on the 14th of August 2003. A power line near Cleveland in Ohio had sagged due to high current. This high current was caused both by high demand and by the temporary closure of a nearby power plant, resulting in more power being drawn through this line. As the line sagged, it came into contact with a tree on the ground below. This caused a short circuit and a surge in current, which was duly detected by the systems in place. The line was taken out of action and the current flowing through it redirected along other nearby lines. This redirection increased the load on those other lines, causing some of them to sag and come into contact with foliage in turn. This was the start of a cascading failure. As one power line after another went down, the problem began to spread and worsen out of control. This situation should have caused immediate alarm and corrective action by the company First Energy Corp, who were responsible for the affected part of the grid. However, First Energy's control room had itself suffered a software issue that effectively silenced the alarms that would normally alert operators to the problem. As such, operators at First Energy were not aware of the problem, and once made aware, were not able to adequately respond to it. One power line after another continued to fail. Within hours, significant parts of the overloaded system started to shut down, and the blackout which followed became unstoppable. First Energy was clearly to blame for the blackout. Not only had their systems failed, but they had also failed to put in place contingencies for such an event, and had also failed to monitor the growth of foliage under their power lines. However, the company faced no penalties, as US law at the time did not have any enforceable standards for such companies. In 2005, such standards were introduced as part of the Energy Policy Act, meaning that providers may face penalties for causing similar, widespread blackouts in the future. Since the 2003 blackout, there has not been another of a similar scale, and it remains the second most widespread blackout ever to have taken place. In total, it affected 55 million people, cost over 100 lives, and made 2 countries aware of just how fragile the grid on which they depend can be.